In section 3.2, we're going to look at measuring angles in radians instead of in degrees. Now, we'll still work in degrees some, but you'll see that there's another unit to use to measure an angle called radians. That's just like if you measure the width of a room, you could use feet, or you could use inches, or you could use yards. It's just a different measurement. But what you have here is the definition of what the measurement of 1 radian would be. This is in reference to a circle. So as it states, in a circle, a central angle that cuts off an arc equal in length to the radius of the circle has a measure of 1 radian. Okay, so what this is describing, of course, if you have a circle, and here is our center. Of course, it refers to a central angle, so that would mean that your angle is going to be formed here at the center of your circle. But when you form this angle, it says that the arc that's cut off arc is going to be the edge of your circle, that the length of the radius and this arc have to be equal to each other. So let's just say this is one side of my angle, and I'm just kind of estimating this. Okay, so this is going to be your angle, your central angle, theta. Okay, so the arc has to be equal to the radius. Okay, so as I said, this is your arc. So if this angle is drawn in such a way that the distance from here around to here is the same as the radius, then that would mean that this angle here is going to measure exactly 1 radian. Okay, now they use the letter S, and I'll talk more details about the variables in just a minute, but they use the letter S to represent the length of the arc, and of course radius we use R. Okay, so again, what this definition is telling us, that R and S have to be equal to each other. They have to be the same. So like if you were to take this and straighten it out and measure it, it would have to be the same as this radius. Okay, now there's a formula that you can use to help you find some of this information, and we have the formula here. Theta is equal to S over R. So theta is, of course, going to be your angle. It's very important that you remember that theta is in radians. So when you use this formula to find the measurement of your angle, it's going to give you the measurement in radians, not degrees. Okay? And as I have already mentioned, the lowercase s is used to represent the length of the arc, and then the lowercase r is used to represent the length of the radius. So all you would have to do is take the length of the arc and divide it by the radius, and that gives you the measurement of your angle, like I said, in radians. Okay, so let's take a look at this example. So you're asked to find the radian measure of theta if the radius is equal to 10 inches and the arc length is equal to 5 inches. Okay, so like I said, this is just simply using the formula. So we just saw that theta is equal to S divided by R. So in this case, S is equal to 5 inches and R is equal to 10 inches. Okay. Now, I went ahead and wrote inches in there because I just want to point something out to you. As you do your work, you don't actually have to write the units. But see, what happens is these units are going to cancel out, and they should, because you're finding the measurement of an angle, and because of that, inches have to go away because your angle, you know, is either measured in radians or in degrees. And of course, in this case, using this formula, it's going to give it to you in radians. Now, you do need to go ahead and reduce your 5 divided by 10. So we'll actually end up with 1/2. and this would be in radians. So there's not a symbol for radians, like degrees, you have the little, degree symbol that you use. So there's not actually a symbol for radians, okay? So this would be considered to have a measurement of half a radian for the angle. All right, a couple little formulas here, just to learn how to change back and forth between degrees and radians. Just like conversions on how to change, from inches to feet to yards, you have conversions for degrees and radians. So if you're asked to change from degrees to radians, so of course that would mean that they're going to give you the angle in degrees. So let's say that they give you 57 degrees. Then what you're to do is to multiply that 57 degrees by pi over 180, and that's what your measurement then would be in radians. Then to change from radians to degrees. So let's say that they start you out with, 2 radians, and you want to know what 2 radians is in degrees. Then you multiply by 180 over pi. So obviously very similar things here that we're going to multiply by. They're just reciprocals, so make sure that you don't get those mixed up, okay? Now here I have a list that you'll need to learn. These are just some of the common conversions, like instead of having to, multiply by pi over 180 all the time, or the 180 over pi. These are angle measurements that we use so much, you just need to have them committed to memory. And honestly, probably by the time you finish the homework assignment for this section, you'll have these memorized. All right, so what I have is the degree measure here for those common angles that we'll use a lot, and then I have the equivalent radian measure, okay? Now you'll see that all of these have pi in them. Not everything has to have pi in it. It just happens, when you're looking at it exactly for these particular angles, that's what you have. But if you remember the definition of your radian went back to a circle. Remember at the very beginning when I talked about the definition of what 1 radian is, and it was based off that central angle on a circle. Think of all the formulas that you have that involve a circle, the area, the circumference, those all involve pi. So that's why you're seeing pi in each one of these, okay? So like I said, you just need to have this list copied down and just simply memorize it. And I'll refer to this several times as I go through the lesson.